guys, welcome back to Tutoring with Abdul. We will be talking about part 2 of measuring instrument. So we talked earlier in that video, and part 1 of this video actually is measuring instruments. We talked about the theories and then we defined the terms of what can be used to measure certain things. For example, for volt we use a voltmeter, for resistance we use a vom or volt ohm milliamp meter, and for amp we use for current we use a amp meter or ammeter. For power we use a watt meter. In this video lecture we will be talking about practical example. We will solve an example here and then we will apply that on a circuit board, and we will measure the current, voltage, resistance, amperage. I'm sorry, I said already current, which is amp, and watt. If we can find out the wattage, we will do it. If not, we will find out wattage in terms of amperage and voltage, because we said we will be finding voltage in the current circuit, amperage in the circuit, and the resistors in the circuit. Okay, so let's talk about that example here. The example is here, a series circuit with 3 resistors. The value is not given, but the color codes are given. It's brown, silver, brown, and gold. The resistor number 2 is brown, green, brown, and gold. Resistor number 3 is orange, brown, and gold, with a supply voltage of 5 volt DC direct current. Find the values of resistor using color codes, and then find voltage drop at each point, and find the total resistance. Find the amperage at each point and total amperage, and find the power at each point and total power. It's asked if you, once you're done with the circuit by solving it, then bring that circuit to the circuit board and measure those quantities using measuring instruments. Okay, let's find out the resistors first. R1 is brown, silver, brown, and gold. R2 is brown, green, brown, and gold. R3 is orange, brown, gold. Brown and gold. One thing we see common in these resistors are the gold. This is the tolerance band. Gold is 5%. Tolerance, lower and upper limit should be assigned by this percentage. Brown color code is assigned to brown is 1. To silver, go ahead to the previous videos, the Ohm's laws video, and there is all these resistors values are given. Please study them, and that will give you a good idea how to measure them, how to find out those values from the color codes. So silver is which is actually okay, so there is a mistake here. So there is no silver, there is a gray. Brown is 1, gray is 8, gray is 8, brown, no, sorry, we have green. Green is 5, and we have orange also, which is 3. So these brown, we got orange, we got green and gray. Okay, so for R1 will be 1. As we said, in assigning values from the color code, we write down the first number and the second number together. So 1, and the brown gray is 8, so it'll be 18. We write down that 18. Then we multiply the third number, third color code, which is brown, and 1. So that will be multiple of 10. That will be, I'm sorry, that will, yeah, so it will be 180. Multiple of 10 will become 180. R2, brown, which is 1, green, which is 5, and the last one is brown also. Will be brown is 1, so 1 is 1, only 1 0. We talked about that in the very like in the first couple of videos, how to compete the measurement from the color code. So it'll be 1 1, and it'll be 151 times 10 will give me 150 ohms. Then R3 finally will give me, which is orange brown, will be 3. These are, you write them as it is, and time, what is brown? 1, so that will be 10 to the 1 is 10. That is our multiplier, so it'll be 330 ohm for that. Since we found these values right here for resistors, it's very important to remember these color codes for the resistors, so that way you don't mess it up. The fourth band here is 5%. It's common in these things. We will find out the resistor, total resistor, and then we will offset the 5% if we have to. Alright, let's go and draw the circuit here. Let's draw the circuit here. There is the circuit for that, and let's find out the total resistance of the circuit. Since it's a series circuit, we will add up all these resistors, R1 plus R2 plus R3. So that will be 330 will give me 660, but 180 plus 150 plus 180 plus 330 will give me 660 ohm. Be 150. Let's do it numerically. 180 ohm plus 150 ohm plus 330 ohm. That will give me 660 ohm together, all total. Now we found the RT, and we have a total supply voltage. We will find total current IT. It's from the ohm formula, will be VT over RT. Total voltage supply is 5 volt divided by 660 ohms. So 5 divided by 660 will give me 0.0075 amp, or we can say that 7.5 milliamp. Since it's a series circuit, I1 will be equal to I2, and this will be equal to I3 because current stays the same. And let's move on to find out V1. Right now it's asked to find a voltage drop at V.1, V1. We select V1 is I1 times R1. I1 is 0.0075 times R1 is 180, and that will become 0.075 times 180 will become 1.35 volt. Now let's find V2. Will be I2 times R2. I2 is 0.075 because it's a series circuit. Current stays the same, and R2 is 150. Okay, 150 ohm. 0.0075 times 150 will give me 1.125 volt. Now finally find V3 here. Will be I3 times R3 will give me 0.0075 times 330. 0.075 times 330 will give me 2.475 volt. If you add these things up, it should give you 5 volt. 1.125. Let's try to figure that out. 1.135. If you add them all, it'll give me 4.95. Pretty damn close. The error is because this 0.75, the amperage was repeated, so that will be a decimal point errors there. So considering that, it's not a bad conclusion there. Okay, so now let's move on to find out P1, P2, P3, and PT. Since we have IT and VT, we can find PT first. PT is equal to total current in the circuit times total voltage in the circuit. Total current is 0.075 times total voltage is 5. So 0.0075 times 5 will give me, PT will give me 0.0375 watts. Now to find, I'm not writing down as a milliwatts, just leave it as it is. Now let's go to the P1. P1 will be equal to V1 times I1. V1 we found was 1.35 times 0.0075. 1.35 times 0.0075. That will give me 0.010125 watts. P2 will give me V2 times I2, and that will give me V2 is 1.125 times 0.0075. 1.125 times 0.0075. That will give me 0.0084375 watts. Now P3 will give me V3 times I3. V3 is 2.475 times 0.0075. That will give me 0.018565 watts. If you add these three numbers, should give you PT, or total power. Okay, PT should be equal to P1 plus P2 plus P3. You guys check that out. If it comes with 0.0375. Okay, so we found all these values here. We found V1, V2, V3, and V also P1, P2, P3. We will move on to the next part of this video. Will be putting those things in a circuit board and measuring it there to see how off we are. Okay guys, so this is a practical circuit here. As you see, this is 5-volt supply connected to the ground. I'm using red and green. Red for hot and green for neutral or common here. Connected 5-volt supply here with a ground being used as a green, and the hot is being used as a red. So these slots are connected individually. So these are all in series and this is all in series too. So I jump from this wire to this slot, so it can be easier for me to jump a wire right here, and the green to the second slot here. We will be sometime talking how to wire a breadboard, but this is just a review how to build a circuit. We got that first resistor here, second one right there, third one right there. As I said earlier, we have to know the color codes here because we don't have any values on this one. We only have the color code. The color on this one is brown, gray, brown, and gold. Brown is 1, gray is 8, and brown is again 1. So that will be 180 ohm on this one. And this one is brown, green, brown, and gold. It will be 150, so it will be 150. And this is orange, brown, and gold. This is 3 times 10 will be 330 ohms. We found the total resistance of the circuit earlier. It was 660. To find, as we said like earlier before lecture, if we have to find the total resistance of a circuit or any resistance of a circuit, we have to put that in turn off the power supply, so we can. And we got 3 resistors, 1, 2, 3. We measured this resistor earlier. We calculated it was 180, close enough. It was 179. The resistor number 2 supposed to be 150 somewhere, 149. And resistor number 3 is, we calculated, was 330. 300, correct. We have because the last band is 5% tolerance, so it will be somewhere in that range. The total resistance we found was a 660 ohm. So let's see if we get that. 657, 55 ohm, pretty damn close. Okay, to find the voltage in each resistor, we have to flip it to the voltage, DC volt. Let's put it in 20, power it on, and see R1 is, oops, sorry, that will be red, should be the supply. R1 is 1.334 volts. Let's see what we have in there as a calculated value. V1 was 135. Let's see what we get it again. 1.33 volts, 1.34 volts. V2, we had a calculated value of 1125. It's 112. The calculated value for V3 was 2.475, 2.46, pretty close. So we got these values. Let's see if we get the total voltage of 4.91, because it's our supply voltage. If we measure that together here, 4.94, and the total voltage coming in here is 4.92, which is pretty close. The error is from the resistance of the wires, has it too. Okay guys, this one is already on a milliamp. I set it up to 20 milliamp, and this is already on a DC volt. Now I'm under 20 volts here too. If I have to measure the amp of this whole circuit, luckily I can do it once because it's a series circuit. Should be same here, here, and here. So to do that, I'll have to disconnect this resistor and connect it through this probe, the red probe, or the hot probe of this multimeter. Please be careful while you're doing this thing, because Since it's only 0.75 amp that I calculated, so I'm expecting some 0.0075 amp, which is 7.5 milliamp. That's I calculated there. Let's see what we get as a value here. Now turn on the power. We got 7.51 milliamp, and we had a 7.5 milliamp as a calculated value, so we are pretty close there. So that's how you just have to cut the circuit, and the amp should go through the meter, and that's how you calculate the meter. Now to find the wattage here, so what I can do is, as earlier I said, I can just find the power with the voltage 4.93, multiply that by this number, which is 0.00751. Whatever give you the number, that's your total power in the circuit. Thank you guys, and that's how you fix it, how you measure the voltage and amperage in a circuit, and also resistance too. One thing you have to make sure that resistance only has to be calculated when the power is off. Do not measure the resistance with power on, otherwise it will burn your meters. Okay guys, this one is already on a milliamp. I set it up to 20 milliamp, and this is already on a DC volt. I'm under 20 volts here too. If I have to measure the amp of this whole circuit, luckily I can do it once because it's a series circuit. Should be same here, here, and here. So to do that, I'll have to disconnect this resistor and connect it through this probe, the red probe or the hot probe of this multimeter. Please be careful while you're doing this thing, because since it's only 0.75 amp that I calculated, so I'm expecting some 0.0075 amp, which is 7.5 milliamp. That's I calculated there. Let's see what we get as a value here. Now turn on the power. We got 7.51 milliamp, and we had a 7.5 milliamp as a calculated value, so we are pretty close there. So that's how you just have to cut the circuit, and the amp should go through the meter, and that's how you calculate the meter. Now to find the wattage here, so what I can do is, as earlier I said, I can just find the power with the voltage 4.93, multiply that by this number, which is 0.00751. Whatever give you the number, that's your total power in the circuit. Thank you guys, and that's how you fix it, how you measure the voltage and amperage in a circuit, and also resistance too. One thing you have to make sure that resistance only has to be calculated when the power is off. Do not measure the resistance with power on, otherwise it will burn your meters.